Start with the 30th example, and here it is said that a square loop PQRS. So here that is the square loop PQRS, and it is carrying a current of 6 ampere, and the direction of current is given as in anti-clockwise sense. This is kept near an infinitely long wire which is carrying a current of 10 ampere in the upward direction. And in the first part of the question, we need to show that the force on PQ and RS are equal and opposite. So let's consider first. So this is the wire carrying current 10 ampere, and let us say I am considering only PQ. As the distance of all elements of the PQ is increasing from the wire from 1 centimeter to 3 centimeter, because wire is kept at x is equal to 0. So if I take a small element dx of the wire which is having current in this direction, so we know that the magnetic force on this element will be, or between two parallel wires is between two wires, or we can say force is equal to I dx into b sine theta. I, that is 6 ampere current is flowing, the length of the element is dx. Magnetic field due to the straight wire at the location of element dx is obviously inward to the plane of the board. So the magnetic field is given by mu naught I upon 2 pi x, and angle is 90 degree. While direction, so the direction can be easily found by the cross product of I and dx. So current 6 ampere is flowing in this direction, which is say x axis, and this is minus k. So what will be the direction? I cross minus k. Okay. So this whole portion will remain as it is, 6 into dx into mu naught I 2 pi x, and we know very well I cross k. So I cross k will be minus j, and this existing minus sign will become plus j. It means the force acting on the element, or the average force acting on this wire PQ due to the magnetic field of this wire, will be in which direction? So obviously the force will be in upward direction. While if we want to find the net force on total wire PQ, so it will be integration of this, where limit varies from 1 to 3, x varies from 1 to 3, and you will get certain answer. But we don't have to solve this completely. Okay. Similarly, from this wire, if I consider the element RS, so in RS element the current is in this direction. Again, if I take at a distance x a small element of this wire dx, so the magnitude of force acting on RS will be same as the magnitude of force acting on PQ, but the direction will be opposite, because current is here and magnetic field is having the same direction. So if we want to find force on element of RS, so it will be I dx into b, while the direction will be current is going in the negative x direction, magnetic field is going in the negative z direction into the inward to the plane of the board, I dx into, so minus minus will become plus, and I cross k will be minus j. It means force acting on RS will be downward direction, it is of the same value. Hence it is being proved that all elements of wire PQ, these are similar to all elements of wire RS, but the direction of current in PQ is towards right, while the direction of current is left. So the total force on PQ upward, total force on RS downward, these two forces will cancel each other, and on these two segment forces they are cancelling each other, and this is being proved. Second, find the magnetic force on the square loop. So what would be the net force on the square loop? Okay, so in the B part, again I will take the same diagram, but now I know that PQRS, when we need to find net force on the wire, so the net force will be vector addition of force on PQ plus force on QR plus force on RS plus force on SP. But as we know very well, the force on PQ and force on RS, they are balancing each other. So the force will be only on PS and RQ. Okay. So current is here. Now when the wires they carry current in opposite direction, they repel each other. When the wires they carry current in same direction, they attract each other. So the net force would be equal to force due to SP minus force due to PQ. And you can apply the formula mu naught I1 I2 upon 2 pi, the separation. How much is this separation? The separation is 1 centimeter, 10 raised to minus 2 meter, minus mu naught I1 I2 upon 2 pi. From the wire, how much is this separation? 3 centimeter, so 3 into 10 raised to minus 2. And you can find the net force. On substituting the values and solving all this, okay, the values of current I1, I2, you will get the answer, okay, that is 1.6 into 10 to the power minus 5 Newton. And as SP is closer to this wire, the force on SP is more than force on RQ. That's why the direction of net force will be rightward, and that is the final answer to this question. Thank you.